You know the story, right? Some brilliant, game-changing machine learning model gets built, and then it just dies. It never sees the light of day. So why does this happen so often? Well, it's because the path from a working model to an actual real-world product is, frankly, a minefield. Today, we're going to demystify MLOps, the whole process that bridges that gap. Okay, this has got to be the classic question. I mean, every data scientist asks this, right? It's that mix of pride and total frustration. You've cleaned all the data, you've trained a model with absolutely incredible accuracy, and inside the nice, safe bubble of your notebook, you're thinking, yes, I've done it. But getting it out of that bubble, yeah, that's a whole different story. And that gap? It's filled with all of these really hard questions that stand between your laptop and a real product. See, it's not just about the algorithm anymore. It's about how do you serve 10,000 predictions per minute? How do you even know if the model is still working next month? What happens if a new model breaks? How do you roll it back? I mean, this is exactly where most ML projects just fall apart. So the bridge across that gap, that's MLOps. It's the set of practices that takes a really promising ML experiment and turns it into a reliable, efficient product. It really is the answer to all those hard questions we just talked about. Okay, so you might be thinking, isn't this just DevOps for machine learning? And that's a fair question, but MLOps is, well, it's more complicated. See, DevOps basically manages code, but MLOps, it has to juggle code plus data plus the models themselves. And its biggest challenge isn't just a simple bug. It's something called model decay. This is when a model's performance just gets worse over time because, the real world it's trying to predict has changed. And that is a unique and constant threat in the ML world. So how do you actually tame all this complexity? How do you fight back against model decay? The answer is a structured, repeatable process. And that's what this is, the 8-stage MLOps lifecycle. Think of it as the complete roadmap that takes a model from just an idea all the way to a product that's continuously improving out there in the real world. So let's walk through each stage, step by step. All right, phase 1 is all about prep and build. The journey really begins here with laying the right foundation. This phase is all about the core data science and engineering work you have to do to build a high-quality model before it ever even gets close to production. Okay, so first step, data collection and versioning. And look, this isn't just about grabbing a bunch of data, it's about cleaning it, validating it, and this is super important, versioning it. The best way to think about it is like Git for data. It's a way to track all your changes so you can always reproduce your experiments. Then, once you have that solid data, you move on to feature engineering. This is really the art of turning that raw data into meaningful signals that your model can actually learn from. All right, now for the really fun part, model training. This is where you take those carefully crafted features and you actually train your model. But here's the thing, it's not a one and done deal. You have to track every single experiment, every parameter, every data set. Then comes the really critical step, model evaluation. You can think of this as the ultimate gatekeeper. Before a model can even dream of going to production, it has to pass a whole battery of tests for performance, fairness, all those quality thresholds. So once a model has been built and it passes that tough evaluation, we're ready for phase 2, deploy and manage. This is all about getting it out into the real world and, well, managing it. Stage 5 is the model registry. And this is so important. Think of it as both a library and another gatekeeper for your models. It's a central hub where all of your approved production-ready models are stored, versioned, and tagged. What this gives you is complete traceability. You know exactly what each model is and precisely where it came from. No more mystery files. And from that registry, we move to stage 6, deployment and serving. This is the moment of truth, really. It's where the model finally starts delivering real value. You take a version from the registry and you make it available to your users, usually as a scalable API that can handle thousands or, hey, even millions of requests. But wait, the job is absolutely not done after deployment. You could argue, in fact, that the most critical part is just beginning. This final phase, maintain and improve, is a continuous loop that makes sure the model stays effective over time. This brings us to stage 7, monitoring and alerting. And this is absolutely essential because a model's performance can degrade silently over time. One of the biggest reasons for this is data drift. That's when the data your model sees in the real world just doesn't look like the data it was trained on anymore. Without monitoring, your model's accuracy could be plummeting and you would have absolutely no idea. You'd be flying completely blind. And that monitoring, it feeds directly into our final stage, model retraining and CI/CD. This is the automated feedback loop that makes MLOps just so powerful. When monitoring detects a problem, like data drift, it can automatically trigger the entire pipeline all over again. It retrains the model on new data, validates it, and deploys a fresh, updated version. It's basically a self-healing system for your model. So there you have it, the full 8-stage life cycle. But why? Why go through all this trouble? Well, the answer is pretty simple. The business impact is just incredible. Let's make this super concrete with a ShopSmart case study. Before they had MLOps, their process was, well, it was a manual slog. It took them 5 months to deploy a single model. Can you imagine? Model files were just emailed to engineers, APIs were built by hand, and when a model failed in production, it could go unnoticed for weeks. But after MLOps, deployment takes 2 days, and monitoring catches drift in just 1 hour. The difference is, quite literally, night and day. Let that number just sink in for a second. A 98% reduction in deployment time. That is a staggering number. That's the difference between falling behind your competitors and leading the entire market. So yeah, the payoff here is huge. You get incredible speed, deploying models way faster. You dramatically reduce risk because you're catching problems like model decay and data drift early. Your data scientists and engineers can finally collaborate effectively on a shared workflow, and you get a system that ensures your models are always adapting to a changing world. So ultimately, it all comes back to that first problem we talked about. MLOps is the bridge. It's what takes that brilliant idea that works on my laptop and transforms it into a robust, reliable product that works for millions of users day in and day out. Which really leaves us with one final question you should ask yourself. Is your model just an artisanal project destined to live and die inside a notebook? Or is it an industrial scale product, truly ready for the real world? Because at the end of the day, the difference is MLOps.